Alright, in this video we're going to look at improper integrals with infinite discontinuities. So if f is continuous on the interval a to b, and notice that it's not including b, and has an infinite discontinuity at b, then the integral a to b of f of x dx is equal to the limit as c goes to b from the left from a to c f of x dx. Okay, so we have an infinite discontinuity at this upper limit here. Okay, it's continuous everywhere else except for this upper limit. So what we'll do is we'll take this upper limit, replace it with some other letter, and then take the limit as c goes to b from the left. Okay, and then in this one it has an infinite discontinuity at a, which is the lower limit. So what we'll do here is replace the lower limit with some letter. We'll do it with c here. And then we'll take the limit as c goes to a from the right. Okay, so if the upper limit, if it has a discontinuity at the upper limit, we'll take the limit as it approaches that number from the left, and if it's the lower limit, we'll take the limit as it approaches that number from the right. And then if f is continuous on AB, so it's continuous everywhere, it's continuous at A and B, except for some number C in the interval AB, at which f has an infinite discontinuity, then the integral a to b f of x dx is the integral a to c plus c to b. So we'll take where it's discontinuous and we'll split it up there. Alright, so let's look at an example. Alright, so here we have the integral 0 to 1 of 1 over the cube root of x dx. Alright, so you can see that this function here is continuous everywhere except for at 0. Okay, this function is not defined at 0. Alright, so we can, well, first before we do anything, let's rewrite it so we'll be ready to integrate this thing. Okay, so I just changed this to x to the 1/3 and then moved it up to the numerator, and that changes the sign of the exponent. Alright, so we notice that it's discontinuous at the lower limit. So we can write that this is the limit as b goes to 0, okay, because it's discontinuous here. Now since it's the lower limit, we're going to come into 0 from the right. Okay, and then that would be b. We're going to replace the 0 with a b to 1 of x to the negative 1/3. And let me write that a little better. X to the negative 1/3 dx. Alright, so now we're ready to integrate this thing. So that's going to be the limit as b goes to 0 from the right. Okay, and now when I integrate this, remember you add 1, so that's x to the 2/3, and then multiply by the reciprocal, 3/2, and we're going from b to 1. Okay. Alright, so now we have the limit as b goes to 0 from the right of 3/2 times 1 to the 2/3 minus 3/2 times, times b to the 2/3. Okay. Alright, so, well, this right here is just 1. 1 to the 2/3 is 1, so that's just going to be 3/2 minus, and then when I take the limit of this term, okay, I'm going to plug the 0 in, so that's 0 to the 2/3, which is just 0, and then 0 times 3/2 is 0, so that term's just going to be 0, and so I get 3/2 as my answer. Alright, so I hope that video helped. I've got several other videos on these improper integrals, and I've got videos on other topics. So if you like them, you can check out my other videos, and you can subscribe. Alright, thanks.